The next chapter which we are going to cover in mathematics is the chapter of continuity and differentiability. The concepts of limits which we did earlier will be used in this chapter. So the first problem which we have, we are given with a function in three different intervals of x. From x belonging to 0 to pi by 4, we have x plus a root 2 sin x. For x belonging to pi by 4 to pi by 2, we have 2x cot x plus b. And for x belonging to pi by 2 to pi, the fx is defined as a cos 2x minus b sin x. And we need to find the values of a and b such that this function is continuous. So in order to proceed with this question, we see that fx has been defined in three different intervals. First is x belonging to 0 to pi by 4, then x belonging to pi by 4 to pi by 2, and x belonging to pi by 2 to pi. So we see that the internal points which are given in the problem are pi by 4 and pi by 2. So we have to check the continuity of the function f of x at these 2 points. So first checking at x equal to pi by 4, we see that the value of function at x equal to pi by 4 is, since the closed interval is at this point, so the value of f pi by 4 will be obtained by putting x equal to pi by 4 in this equation. So we get 2 into pi by 4 plus b, which is equal to pi by 2 plus b. We know that for the continuity of any function, the left hand limit of the function at that point is equal to right hand limit of the function at that point is equal to the value of function at that point. We have obtained the value of function at pi by 4 equal to pi by 2 plus b. Now we have to find the values of the limits of the function just before pi by 4 and just after pi by 4. So for f pi by 4 minus, since the interval of pi by 4 minus is this, so we get limit h tending to 0, we put x equals pi by 4 minus h in this equation to get limit h tending to 0, pi by 4 minus h plus a root 2 sine of pi by 4 minus h. On putting h equal to 0, we get pi by 4 plus a root 2 into sine pi by 4, which is 1 by root 2, so pi by 4 plus a. Now we check for f pi by 4 plus. The pi by 4 plus interval is this one, so it becomes limit h tending to 0, 2 into pi by 4 plus h, we put x equals pi by 4 plus h into cot of pi by 4 plus h plus b. On putting h equals 0, we get 2 into pi by 4, which is pi by 2, cot pi by 4 is 1 plus b. So left hand limit at x equals pi by 4 is pi by 4 plus a, our right hand limit is equal to pi by 2 plus b, and the value of function at x equals pi by 4 is pi by 2 plus b. So for the function to be continuous at x equals pi by 4, the left hand limit at x equals pi by 4 should be equal to the right hand limit at x equals pi by 4 should be equal to the function's value at x equals pi by 4. So pi by 2 plus b should be equal to pi by 4 plus a, and we can easily see that the right hand limit at x equals pi by 4 is already equal to the values function or the function's value at x equals pi by 4. So here we get pi by 4 is equal to a minus b. This is the first equation. Now we do the same calculations for x equals pi by 2. First of all, we will find out the value of function at x equals pi by 2. Since the closed interval is this, so the value of x equals pi by 2 will be obtained by putting x equals pi by 2 in this equation. F pi by 2 is equal to 2 into pi by 2, which is pi, cot pi by 2 is 0 plus b. So f of pi by 2 is equal to b. Now the left hand limit at x equals pi by 2, it is equal to, this is the left hand limit at x equals pi by 2, so 2 into pi by 2 minus h, cot of pi by 2 minus h plus b, limit h tending to 0. Since this was the interval of pi by 2 minus, so we obtain the value of left hand limit at x equals pi by 2 by putting x equals pi by 2 minus h in this value of function. On putting h equals 0, we get 2 into 0, or rather 2 into pi by 2 into cot of pi by 2, which is 0, plus b, which is equal to b. The right hand limit at x equals pi by 2, since this is the interval of pi by 2 plus, so we put x equals pi by 2 plus h in this equation to get a cos 2 times pi by 2 plus h minus b times sine of pi by 2 plus h. On putting h equals 0, we will get a into cos pi, which is minus 1, so minus a, and this sine pi by 2, which is equal to 1, so minus a minus b is the value of right hand limit. Now for continuity at x equals pi by 2, we have left hand limit at x equals pi by 2 should be equal to right hand limit at x equals pi by 2 should be equal to the value of function at pi by 2. Since the left hand limit at equals pi by 2 is already equal to this, so we just equate left hand limit and the right hand limit at x equals pi by 2, so that we get b equals minus a minus b, so a equals minus 2b. So we get two equations in a and b. So on solving these two equations, we get a equals pi by 6 and b equals minus pi by 12. So for the function given in three intervals 0 to pi by 4, pi by 4 to pi by 2 and pi by 2 to pi, we check the continuity of the function at x equals pi by 4 and x equals pi by 2 and got the final answer of a and b as a equals pi by 6 and b equals minus pi by 12.